Hello, Miss Thinker here, your daily source for mind-blowing facts, forgotten history, and powerful motivation. Today, I will talk about why the universe is expanding. Imagine waking up tomorrow and discovering that everything around you, your city, your planet, even your galaxy, is slowly moving away from everything else. It sounds impossible. But that's exactly what's happening right now, not just here, but everywhere in the universe. The cosmos is expanding. But why? What force could possibly stretch space itself? Tonight, we explore one of the greatest mysteries in science. Why is the universe expanding? In the early 1900s, scientists believed the universe was static, eternal, and unchanging. Then astronomer Edwin Hubble made a discovery that shocked the world. While studying distant galaxies, he noticed something strange. Almost all of them were moving away from us. Not drifting randomly, but systematically. The farther away a galaxy was, the faster it was receding. This observation became known as Hubble's law, and it revealed something revolutionary. The universe isn't static, it's expanding. When scientists say the universe is expanding, they don't mean galaxies are flying through space like rockets. They mean space itself is stretching. Imagine drawing dots on a balloon and inflating it. As the balloon expands, all dots move away from each other, not because they're moving on their own, but because the surface between them is growing. That's what's happening to galaxies. Even our home galaxy, the Milky Way, is being carried along by this cosmic expansion. To understand why the universe is expanding, we have to go back nearly 14 billion years, to the beginning. Scientists believe the universe started in an event known as the Big Bang, not an explosion in space, but an expansion of space. At the very beginning, everything was compressed into an incredibly hot, dense state. Then space itself began stretching outward. And it never stopped. The expansion we observe today is actually the continuation of that original cosmic expansion. Years before the expansion was observed, physicist Albert Einstein developed his theory of general relativity. In the first fleeting moments of existence, our universe experienced an expansion so violent, so unimaginably fast, it's called cosmic inflation. In less than a trillionth of a second, a region smaller than an atom swelled to become larger than a galaxy. This explosive growth smoothed out the cosmos, setting the stage for the grand structures we see today. But what triggered this incredible event? The answer remains one of the deepest mysteries in physics, a whisper from the very dawn of time. Everywhere we look in the sky, there is a faint, ancient glow. It's the cosmic microwave background, the oldest light in the universe. This is the afterglow of the Big Bang itself, a fossil radiation from a time when the entire cosmos was a hot, dense fireball. Imprinted on this light are tiny temperature fluctuations, the seeds from which all galaxies, stars, and planets eventually formed. By studying this echo of creation, we are reading the baby pictures of our universe, just 380,000 years after its birth. His equations described how gravity shaped space and time. But when Einstein applied them to the universe, they predicted something surprising. The universe shouldn't stay still. It should either expand or collapse. At the time, Einstein didn't believe this. He actually added a mathematical term to force his equations to produce a static universe. Later, after Hubble's discovery, Einstein reportedly called that adjustment his greatest mistake, because the universe really was expanding, just as his original equations predicted. For decades, scientists assumed expansion should slow down over time because gravity pulls everything together. But in 1998, astronomers discovered something shocking. The expansion isn't slowing. It's accelerating. Galaxies are moving away from each other faster and faster. Something unknown is pushing space apart. Scientists call this mysterious force dark energy. It's invisible, undetectable directly, and it makes up most of the universe. Whatever dark energy is, it's stronger than gravity on cosmic scales. Organizations like NASA study expansion using powerful telescopes and cosmic observations. As we gaze into the cosmos, we find that the stars and galaxies we see are just the tip of the iceberg. An invisible substance, a cosmic ghost, holds everything together with its immense gravity. We call it dark matter. It doesn't shine, it doesn't reflect light, it doesn't interact with anything we know, yet it makes up over 80% of all matter in the universe. We know it's there by the way it bends starlight and corrals galaxies, but what is it? The hunt for this elusive particle is one of the greatest quests in modern science. Scientists measure galaxy motion, background radiation from the early universe, supernova explosions billions of light years away. By combining these observations, they can calculate how fast the universe is expanding, a value known as the Hubble constant. But here's another mystery. Different methods give slightly different answers, which means we may still be missing something fundamental about how the universe works. In the deepest voids of space-time, where gravity bends light and shatters the laws of physics, lurk the universe's most enigmatic monsters, black holes. These are points of infinite density, cosmic whirlpools so powerful that not even light can escape their grasp. They are the remnants of colossal stars, collapsed under their own immense weight, creating a one-way door out of the known universe. What lies beyond their event horizon remains one of science's most profound and unsettling questions. Rippling silently through the fabric of the cosmos are gravitational waves, echoes from the universe's most cataclysmic events. First predicted by Einstein, these tremors in space-time are created by the collision of black holes or the explosion of stars. For a century, they were purely theoretical, but now we can detect them, opening a new window to the cosmos. It's like we've suddenly gained the ability to hear the universe's secret symphony, a grand and violent orchestra playing out across billions of light years. But as we listen, a cosmic dissonance emerges, what scientists call the Hubble tension. By measuring the universe's expansion in different ways, we arrive at two conflicting numbers. It's as if the universe is expanding faster than our best theories predict. This discrepancy suggests that our understanding of cosmology is incomplete. Are we missing a fundamental piece of the cosmic puzzle? Is there a new physics waiting to be discovered, one that could rewrite everything we thought we knew? Scientists aren't sure what the ultimate fate of the universe will be. There are a few possibilities. 1. Endless expansion. Galaxies drift farther apart forever, stars eventually burn out. The universe becomes cold and dark. 2. Big Rip. Expansion accelerates so much that galaxies, stars, planets, even atoms are torn apart. 3. Slowdown and collapse. If gravity somehow overcomes expansion, the universe could eventually contract. Right now, observations suggest expansion will continue indefinitely. The universe is expanding in every direction all the time. Not because something is pushing galaxies outward. Our universe, with its billions of galaxies, might not be alone. The laws of physics that led to our Big Bang could have happened again and again, creating a vast cosmic ocean of separate universes, each with potentially different laws of nature. This is the multiverse theory. Are we just one bubble in an infinite cosmic foam? While we can't yet see these other worlds, the possibility forces us to reconsider our place in the grand scheme of reality. The cosmos may be infinitely larger and stranger than we ever imagined. But because space itself is growing, and the most incredible part? We're still figuring out why. Perhaps the answer lies in the strange and beautiful world of string theory. This radical idea proposes that at the most fundamental level, everything is made not of particles, but of tiny vibrating strings of energy. Different vibrations create different particles, just as different notes on a violin create different sounds. String theory promises a unified theory of everything, connecting gravity and quantum mechanics in a single elegant framework. While still unproven, it paints a picture of a universe far stranger and more intricate than we could ever have imagined. The expansion of the universe reminds us that reality is bigger, stranger, and more mysterious than we ever imagined. If you could ask the universe one question about its secrets, what would it be? Tell us in the comments. And don't forget to like and subscribe for more journeys into the cosmos, because out there, the universe is still unfolding.